Hey everyone, this is Tom from Tutor Bros. Today we're going to learn how to write a polynomial in nested form, which means it will contain only linear expressions. The benefit of doing this is that it makes it easier to evaluate a polynomial when you're using a calculator. So with that said, let's just jump right into it and we'll see how this is done. We'll take a look at our first example. We have f of x equals 3x cubed minus 2x squared minus 5x plus 8. The first thing we want to do is we want to group all the terms together that have x's in them. So when we do that here, we'll have f of x equals parentheses 3x cubed minus 2x squared minus 5x, close parentheses, and then plus 8 on the outside. The next thing we're going to do is we're going to factor out as many possible x's as we can from the terms in the parenthetical expression. In this case, we can factor out 1x. And incidentally, when we do that, we're going to put the x on the right-hand side of the parenthetical expression as opposed to on the left-hand side, which we normally do. So we will do that here. When we factor out an x, this becomes 3x squared minus 2x minus 5. And then the x we factored out, we'll put it right here, and then still plus 8. And then we simply repeat that process as many times as necessary until we reduce our polynomial to one that includes only linear expressions. So when we go back to this one and we do the next step, we'll take a look at all the terms inside the parentheses. We will group the ones together that have x's in them, and then we will factor out as many x's as we can, then just repeat that as needed. So if we look at the parenthetical expression here, we have 3x squared minus 2x. Those are the last two terms that have x in them. So we'll group those together and then we'll factor out an x again. And when we do that, we'll do f of x equals, now since we're doing grouping inside of grouping, we'll use brackets. So this now becomes 3x minus 2. And then this is the x we factored out of those two terms, still subtracting 5. All of this contained within brackets. This will be the original x that we factored out previously, and then plus 8. So this is actually going to be our final answer. You see that we've reduced our original third-degree polynomial to one that contains only linear expressions. Alrighty. So let's do another example problem together. Now we have f of x equals 3x to the 4th minus 6x cubed minus 5x plus 10. So this one, you'll notice, is a fourth-degree polynomial, whereas previously we had a third-degree polynomial, but the process remains exactly the same. So the first thing we'll do, we'll group all of our terms with x's together. So we have f of x equals parentheses 3x to the 4th minus 6x cubed minus 5x, close parentheses, plus 10. Then we'll factor out an x. F of x becomes 3x cubed minus 6x squared minus 5. There's the x we factored out, plus 10. Then we'll go back to the expression in parentheses. You'll see we have two terms left that have an x in them, so we have 3x cubed minus 6x squared. So we can actually factor out x squared from those two terms rather than just x. And when we do that, so we'll do f of x equals, we'll use the brackets again. So remember, we're factoring out x squared, so this becomes 3x minus 6. And then out here on the right-hand side of the parentheses, we're going to write x times x rather than x squared, because remember, the whole purpose of writing a polynomial in nested form is so that the polynomial is expressed only in linear terms. So instead of doing x squared, we'll do x times x. And then we're still subtracting 5 here. All of this is contained within the brackets. Here's the original x we factored out, and then plus 10. And that would be our final answer. We've reduced our fourth degree polynomial to one that contains only linear expressions.